Hello, my dear student of class 10, English version. Hope all of you are well and safe. I am also safe till now by the grace of Almighty Allah. I am the Zuhair Islam Choudhury, lecturer in chemistry, English version day shift, Raju Guttora Model College, is going to start an important lesson from chapter 11. Today's topic is saturated hydrocarbon. I'll discuss about the naming of this hydrocarbon and preparation of this hydrocarbon and physical and chemical properties of saturated hydrocarbon. So let's start for today's lesson. At first, if you know what is saturated hydrocarbon or alkane, the hydrocarbons which have only carbon-carbon single bond in their carbon chain are called alkanes. No carbon-carbon double bond and carbon-carbon triple bonds are present here. The hydrocarbons which have only carbon-carbon single bond is present in their carbon chain are called alkane. The general formula or common formula of alkanes is CN plus 2. Here N equal to 1, 2, 3, etc. When N equal to 1, that is called methane, the formula will be CH4. When N equal to 2, it will be ethane. That formula is C2H6 or CH3CH3. When N equal to 3, the name of alkane will be propane, and the formula of propane is C3H8 or CH3CH2 CH3. Similarly, for N equal to 4, butane, N equal to 5, propane, N equal to 5, sorry, pentane, hexane, heptane, octane, nonane, decane, and so on. Why alkanes are called paraffin? The word paraffin derived from Latin word param mean less and affinis mean affinity. So paraffin mean compound of less affinity. In alkanes, strong carbon-carbon and carbon-hydrogen covalent bonds are present. Remember, covalent bonds are two types, pi bond and sigma bond. Sigma bond is stronger bond than pi bond. Any single bond means sigma bond. So these compounds generally don't take part in chemical reaction. That is, they don't react with acid, base, metal, oxidant, reductant, etc. etc. Alkanes are chemically inactive to great extent. So they are called paraffin or compound of less affinity. Now we are going to start what is alkyl group and its naming. The single valency radical formed after removing one hydrogen atom from the alkane is called an alkyl group. Again, when one hydrogen atom is removed from alkane, then the produced monovalent radical is known as alkyl radical or alkyl group. Here, monovalent mean group or radicals that valency is 1. The general formula of alkyl radical is CN is twice n plus 1. Here, hyphen mean 1 bracket valency. And we normally use capital R to express the alkyl radical. Naming of alkyl radical is very simple. Alkyl radicals are named by omitting ane from alkane and just add YL with the last part of the name of alkane from which a hydrogen atom was removed for formation of alkyl radicals. For example, when one hydrogen is removed from methane, then we'll get methyl radical. When one hydrogen is removed from ethane, we get ethyl radical, and when one hydrogen is removed from propane, then we'll get propyl radical. Similarly, butyl from butane, pentyl from pentane, etc. Naming of alkanes. Rules for naming of alkanes in IUPAC is as follows. The full form of IUPAC means International Union of Pure and Applied Chemistry. Point number one, you have to take the longest continuous carbon chain as the parent. At first, you have to count the longest continuous carbon chain. Secondly, name the groups or branches attached to this parent chain. Remember, after counting longest carbon chain, the rest of the groups are called substituent or branches. Number three, number the chain consecutively starting at the end nearest the substituent group. Please remember, you have to count the longest carbon chain. You have to give number to the carbon chain, keeping branches at least number. Okay. Number four, designate the location of each group by an appropriate number and name. You have to locate the substituent groups. Number five, assemble the number listing groups in alphabetic order. You have to mention the group in naming according to English alphabetic order. Number six, the prefixes di is for two same alkyl group, tri for three alkyl group, three same group, and tetra for four same group, etc. etc. Are used to designate several groups or same kind. And here's some example of naming of alkane. Number one, you may count the longest carbon chain from left to right or right to left, 1, 2, 3, 4, 5. But if you count from left to right, the position or location of the substituent at position 4. But if you count from right to left, then the position of this group at number 2, which is lowest number. So you have to count from right to left. 1, 2, 3, 4, and 5. So the name of this compound will be 2-methyl. Because why 2-methyl? Because this methyl group is attached with carbon number 2. So 2-methyl pentane, 1, 2, 3, 4, 5. 5 carbon containing alkane, that is pentane. 2-methyl pentane, the name of this compound. Similarly, this is 1, 2, 3, 4, 5, 6, 7 carbon containing alkane, that is heptane. You have to count from left to right, and at carbon number 2, one methyl is present and another methyl is present at position 3. So the name of this compound will be 2,3-dimethyl, 2-methyl group present here. So dimethyl, 2,3-dimethyl, 2,3-dimethyl heptane. Okay, 2,3-dimethyl heptane. And number 3, for number 3, you have to count from left to right. 1, 2, 3, 4, 5, 6. Here at position 2, 1 is methyl, and at position 3, ethyl group is present. So alphabetically, you have to mention ethyl group at first. So the name of this compound will be 3-ethyl, 2-methyl, 1, 2, 3, 4, 5, 6. 6 carbon containing alkane, so it will be hexane. 3-ethyl, 2-methyl hexane. Okay, 3-ethyl, 2-methyl hexane. And similar naming is applicable for group, for example, 4 and 5 also. which is 4-ethyl 2,3-dimethylheptane. 4-ethyl ethyl group is positioned at number 4, and 2-methyl is present 2 and 3 position. So the name of this compound will be 4-ethyl 2,3-dimethylheptane, 7 carbon containing longest carbon chain, that is parent chain. And here you have to count, but you have to give number from right to left, because if you give from left to right, the position of these substance will be low, will be highest number. But if you count from left to right, then this group will be stay at lowest number. So you have to count from right to left. That is 1, 2, 3, 4, 5, 6. And the name of this compound will be 3-chloro-2-methyl-hexane. Alphabetically, chloro comes from methyl, because chloro starts with carb C, and methyl starts with M. So alphabetically, chlorine or chloro comes first, then methyl. So the name of this compound will be 3-chloro-2-methyl-hexane. Now I'll discuss about the preparation of alkane. Several preparations system of alkanes are available. Number 1, from carbon dioxide. Methane is prepared from carbon dioxide and hydrogen in presence of nickel catalyst at 250 degrees Celsius temperature. Please see here, methane and water are produced when hydrogen heated with carbon dioxide at 250 degrees Celsius temperature in presence of nickel catalyst. Number 2, from alkene and alkyne. Okay, this reaction is known as hydrogenation reaction, addition of hydrogen. It is a hydrogenation reaction. When hydrogen reacts with ethene, in presence of nickel catalyst at 180 to 200 degrees Celsius temperature, then we'll get ethane. Here one hydrogen is attached with this carbon, and one hydrogen atom is attached with this carbon, and we'll get CH3 and CH3, and this double bond will be converted into this single bond. Okay. Similarly, 2 hydrogen molecule or 4 hydrogen atom reacts with ethane and produce ethane. 2 hydrogen atom attached with this carbon, and 2 hydrogen atom attached with this carbon, and then we'll get CH3, that is ethane. Okay, and this reaction is called hydrogenation reaction. Okay, this, because here hydrogen is attached with these unsaturated hydrocarbons and produce saturated hydrocarbon. These reactions are known as hydrogenation reaction. And very important reaction, decarboxylation reaction, that is used to prepare alkane. Here, methane can be produced when sodium ethanoate is heated with sodium hydroxide and calcium oxide. Here, this part is removed. And produce sodium carbonate, and this hydrogen attached with this carbon and produce methane. Please observe, In reactant site, 2 carbon atoms are present, but in main product, that is methane, 1 carbon is present. Decreasing of 1 carbon is occurred. For this reason, this reaction is known as decarboxylation reaction. Similarly, ethane is prepared from sodium propanoate. Here, 3 carbon atoms are present, and in product side, 2 carbon atoms are present. And this part is removed from and produce this compound, that is sodium carbonate. And this hydrogen is attached with this carbon, and produce CH3CH3, that is called ethane. Here also a decreasing of 1 carbon is occurred. So it is also decarboxylation reaction. Now I'll discuss about what is the physical properties of alkane. Normally, the physical properties of alkane depends on the number of carbon atom. The increasing of carbon atom, the boiling and melting point of alkane also be increased. Here, alkane containing 1 to 4 carbon atom, they remain in gaseous state. They remain in gaseous state. And alkane containing 5 to 15 carbon atom, they remain in liquid state. And alkane containing more than 15 carbon atom, they exist as solid state. Now, I'll discuss about the chemical properties of alkane. Normally, alkanes are chemically inactive to great extent. However, they take part in some chemical reaction, that is combustion reaction and substitution reaction. Methane reacts with oxygen of air, and thus carbon dioxide and water vapor and heat are produced. This heat is used for cooking or different purpose. Remember, reaction with oxygen is called combustion reaction. In combustion reaction, always heat energy is produced. Here, methane reacts with oxygen. It means methane burns and produce carbon dioxide, water vapor, and heat energy. This is the characteristics reaction of alkane, halogen substitution reaction. Halogen substitution reaction is the characteristic reaction, the main reaction of alkane. Here, tetrachloromethane is produced when chlorine is mixed with methane in presence of sunlight or ultraviolet light or UV light. This reaction is the combination of four steps. Step 1, at first methane reacts with chlorine in presence of ultraviolet ray and produce chloromethane. Here, 1 hydrogen atom is replaced by 1 chlorine atom, and another chlorine atom reacts with the substituted hydrogen and produce hydrogen chloride. In this way, chloromethane is produced from methane. Similarly, methyl chloromethane reacts with chlorine. Here, 1 hydrogen atom is also replaced by 1 chlorine atom. Here, increasing of chlorine atom is occurred and decreasing of hydrogen atom is occurred and produce methylene chloride. Similarly, dichloromethane reacts with chlorine and produce trichloromethane or chloroform and hydrogen chloride. And trichloromethane also reacts with chlorine and produce tetrachloromethane. Okay, remember this chloromethane, dichloromethane, trichloromethane, tetrachloromethane. Among these 4 halogen substituted compounds, tetrachloromethane is more toxic more toxic. The increasing of chlorine atom, the toxicity also increased. Now I'll discuss about some important question. That is number 1. Please, it's for homework. Write the structural formula of 2,2-dimethylbutane. Number 2 question. Write IUPAC name of this compound. Prepare propane from propine. Prepare propane from propine by using halogenation reaction. It can be prepared. Prepare ethane from propanolic acid by decarboxylation reaction. Boiling point of octane is more than butane. Is carbon number fact. More carbon number, boiling point also increased. Ethane is saturated hydrocarbon because maximum hydrogen atoms are attached with carbon of ethane. Maximum hydrogen present in ethane compared to ethene and ethine. So this compound is hydrogen saturated. So they are called saturated hydrocarbon. Number 7, alkanes are called paraffin. You have already know what is the reason, because compound-less affinity. Explain the term of decarboxylation reaction, and that's of all. Thank you for being with me. Thanks to all. Please stay home and stay